Most of us in fisheries, forestry, wildlife, species conservation, and similar ecological fields have a science-related academic background. However, such disciplinary backgrounds alone rarely prepare us for real-world ecological-oriented management or policy. Also, science itself, an appealing comfort zone for most of us, is often politically contentious. And even with complete scientific information, many natural resource issues remain controversial and play out against a background of lawsuits and court deliberations. Thus, science itself is only part of most ecological policy debates, but it is potentially an important component. But scientists can also misuse scientific information, both inadvertently through ignorance or as a tool in intentional policy advocacy. Today, for many natural resource issues, managers must consider the reality of a changing climate that does not favor publicly or politically valued species. Think about two current challenges for policymakers. First, restoring much reduced runs of salmon given a rapidly expanding regional human population and superimposing a changing climate. And the second example, sustaining marine catches given the escalating demand for seafood, protecting at-risk species when little remains of their optimal habitat, and the reality of changing climate. Yes, science is important, but unfortunately, science these days is often not trusted to be a credible source of useful information. Let's consider why. As a scientist, I argue that unless we are more vigilant in guarding against the misuse of science in natural resource policy and management, we, practicing scientists, risk marginalizing the helpful role that science and scientists can play in resolving important but divisive natural resource issues. Precise definitions are important in delineating the proper role of science in policy analysis and decision making. I define science as information gathered in a rational, systematic, testable, and reproducible manner. It is not limited to the hypothesis testing frame of the classical scientific method, nor does it preclude disciplines such as astronomy and anthropology. Correspondingly, I define a scientist as a person who gathers or interprets scientific information, i.e., science. Thus, not all individuals possessing scientific credentials are working as scientists, even though they may be identified as scientists and hold scientific degrees. An understandable impulse by those of us who work on natural resource or ecological issues, including scientists, is to insert our opinion about what we think should be the appropriate public policy goal or choice. In short, a tendency to express a personal policy preference. Of course, policy preferences are formed by a mixture of personal values and what the facts are perceived to be. Of course, we often self-select to our disciplines, i.e. fisheries, wildlife, forestry, conservation biology, because some of us value such environments or animals. Thus, in our professional lives, we tend to be surrounded by others of like mind. For example, it is easy to slip into the mode of, quote, everyone I know thinks that restoring wild salmon is more important than providing hydropower, while failing to realize that such a view is only one of many competing, often mutually exclusive policy trade-offs. Personal policy preferences aside, science deals with the fact side of policy. We are usually admonished in university classes to separate our science from our personal policy preferences, because policy debates are, in large part, clashes of conflicting values and competing alternatives. For deciding who wins and who loses, i.e. the political process, science is important, but it is only one element used to select from among competing policy alternatives. It is often easy to identify when a scientist has shifted from the role of provider of scientific information to the role of advocate of personal or employer policy preference, but sometimes it is not. At times, even a conscientious scientist may be unknowingly advocating a personal or employer policy preference by conveying biased scientific information. For example, how common is the implied policy preference for naturalness embedded within what is ostensibly policy neutral science? I think it is very common. As I read some of the scientific literature that comes across my desk, it appears that many scientists tacitly accept the view that natural and undisturbed for any ecosystem is inherently preferable to altered and disturbed. Thus, it follows that native species are fundamentally more important than non-native or exotic species, and therefore, by implication, biological diversity should not be reduced. Knowing what species are native may be essential for testing certain scientific hypotheses, but conveying scientific information with such an implied policy preference is a form of policy advocacy. I offer 3 examples to illustrate. First, consider the widely held notion of ecological integrity. It is very common in scientific literature. Ecological integrity is, by common definition, based on native species and, by implication, native ecosystems. Perhaps in the narrowest legalistic sense, the definition is purely scientific, in that it states no implied policy preference. However, to the average person, the use of the word integrity connotes goodness or desirability. To the careless listener or reader of such scientific information, it easily follows that human activities, i.e., altering what is natural, are inherently bad or adverse. I believe it is reasonable to conclude that to most people, if unaltered ecosystems are defined as inherently good, i.e., having the highest ecological integrity, and the point of reference for the desired ecosystem condition, then human actions that alter ecosystems must be adverse. Of course, selecting a policy option from among the viable choices is based on values and preferences. But the science that is provided by experts to inform such a choice should not presuppose what those societal values and preferences are or should be. Consider a second example, the several decades old notion of ecosystem management, or its latest incarnation, ecosystem-based management, the hallmark of many natural resource and regulatory agencies. Terms such as degradation, health, and impoverishment are frequently used in the scientific literature about ecosystem management, and they imply that the appropriate and ideal target for ecosystems is a condition with little or no human disturbance. By implication, the use of such terms implies that human disturbance results in some degree of degradation, something less than healthy. Thus, the line between science and values in many formulations of ecosystem management has been, if not completely erased, muddled beyond clear interpretation. The use of normative concepts such as degradation, health, and impoverishment has no place in the scientific literature. It may be effective advocacy, but it is not science. In the scientific literature, when addressing notions of ecosystem management, the importance placed on the pedigree of a species present in an area also shows a common acceptance of the policy corollary that native species are more important than exotic species. Exotic species, like this barred owl, part of a thriving Pacific Northwest population, may be called invasive, but their status is usually less obviously stated. Today, they have largely replaced the native spotted owl. Exotic species are routinely excluded from measuring biological diversity. But why are native species more important, policy-wise, than exotic species? Further, among exotic species, why are intentional introductions usually treated differently than unintentional introductions relative to biological diversity? Such choices are policy decisions. There is nothing in science that indicates that society will prefer or should prefer one species over another. Consider a third example of the scientific literature with embedded policy preferences. Specifically, to what goal or target should society restore? Should ecological restoration be aimed at recreating the ecological conditions that existed at the beginning of the Holocene, or just before 1492, or at the end of just last week? The answer requires making a value judgment, a policy choice that is necessarily a political judgment. It is not a scientifically derived decision. Yes, scientists should assess the feasibility and ecological consequences of achieving each possible restoration target, but selecting from among the choices is a societal enterprise. Scientists are not policymakers. In ecological restoration, individuals in society may value certain species more than others, or all species may be valued equally. Such determinations are societal preferences to be made by the public or its institutions, not by scientists working under the guise of technocrats providing policy-neutral facts. Further, whether society prefers natural and undisturbed to altered and disturbed ecosystems is purely a societal judgment. There is nothing inherent in science that makes either pristine or altered ecosystems inherently better or preferable from a policy standpoint, nor is one restoration target more or less desirable than another. Without a clear separation between providing policy-neutral science and advocating for personal or employer policy preferences, scientists risk being categorized as yet one more policy advocacy group pitching a policy preference. Worse, the scientific enterprise risks being treated as policy advocates who present information in ways that sound like science, read like science, are presented by individuals who cloak themselves in the accouterments of science, but who are actually offering policy advocacy masquerading as science. In a democracy, having widely available, accurate, understandable, and unbiased scientific information is central to successfully resolving the typically contentious ecological policy issue. To allow science to be marginalized through misuse is a major loss to society and its decision-making institutions. When performed appropriately and without policy bias, science has much to offer society, decision-makers, and individual citizens. But the scientific enterprise has much to lose by doing otherwise. Any personal bias for natural, pristine, or any other ecosystem state, no matter how understandable in its motivation, has no place in the scientific enterprise.